Welcome to a new test and teardown video. Nothing is too big and complicated. Nothing is too small and simple. I take it all, and especially if it's an HP. This one is a 350D attenuator set. So what this does is we got 600 ohms of input and 600 ohms of output impedance. And then you can just set the attenuation. So one knob is 10 dB steps and the other knob is 1 dB steps. It's actually that simple. Everything is quite well explained here at the front. 5 watts, 55 volts, and the range is from DC to 1 megacycles. And of course it depends a little bit on the specifications. Let's just briefly look at the specifications. I downloaded the data from HP Archive, and on this manual what I see here is the age of this product, 1962. Blah 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 blah. Let's go down to the specific. Yeah, here it is. So this is the specifications. This is really impressive. So from DC to 100 kilohertz. Look at that, 0.125 dB. Isn't that just amazing? But this is of course the 10 or the 1 dB step. Then let's go to the 10 dB step. Then it's a quarter of a dB. And then obviously if you go up to a higher frequency and any step up to 70 dB, less than 0.5 dB. Alright, so this is the specifications. Let's perform a little bit of measurements. See, the first measurement I'm gonna do is I'm gonna take my ohm meter. I'll put it in 0 dB attenuation. So in this very special mode, the 600 ohm impedance is really not a thing, isn't it? Because look, input here is not connected to ground, but input is directly connected to output. So that is the pass through. So let's try the same in 10 dB attenuation. Now I'm measuring from input to output and I see 727 ohms. Let's try the 1 dB step and dial this up to 10 and I see more or less the same. So now the meter just goes, that's funny. So I got a meter range thing. Oh, that is actually really funny. My meter just happens to change ranges exactly there. All right, so now we're going into 600 ohm mode, and obviously the higher I go here, the closer I go to 1200. Okay, now you'll see what happens. See, 1100. So this is what, 30 dB, 40 dB. 50, yeah, and from now on you're not going to see a big change here because the ground resistor will be about 600 and then the resistor from the input to output is now so high it's not contributing to the value that I'm measuring here, right? So look what happens. Oh, I have a little bit of a loose connection. Let's try again. 1204. So, okay, this is just the accuracy from the different dividers. It's very close to 12. Hello? Why are you doing that? Okay, so we just need to massage the switch a little bit. And then we're back again. So, let's try and measure the input to ground. And that is very close to 600. And of course I can measure ground to ground and that will be 0. Yeah. So I can also measure the output and this is also about 600. So it's going to continue all the way up to here where we see the, see, 20, and now, see, it's going to go up, and then there is no connection. Let's try, oops, let's try and do the same. 1 dB, you see? Aha, there's a problem again. So we see that, just massage the switch a little bit. Going to 1, yes. I am not happy. Come on, man. Okay, that was better. Now we have a connection. So this is how you clean switches, ladies and gentlemen. Ooh. This one is probably not so clean. Oh, now it's gonna, yes, look at that. So now it's better. Yeah. So I'm going to massage the switches a little bit, and I really look forward to see if I'm able, how much of this range am I able to verify with modern equipment. I think I need an amplifier or something to be able to detect the lowest levels, because this is really super attenuation, not that easy to verify. So now I'm trying to test this with DC. So I put it into 0 dB. I got 600 ohms of drive impedance, and I put almost 600 ohms on the output. So of course now in the 0 I'll get half of my input voltage, right? So that means I have fine calibrated the input voltage, so I read 10 volts of output. So far, so good. So this is the 0 dB, right? So now I go to 10 dB, and obviously I'm gonna see 3.15. Haha! So this is pretty close, isn't it? And let's try and do the same with this one. 3.15. So I'm super happy about that. So what happens, because this is of course voltage division, so 20 dB is a factor of 10. So I should read I should read 1, right? So see, 0 dB is 10, click, click, that is 20 dB down here, and I should get about 1. So far so good. So we skip 30 is 317, 40, haha, see? 50 again, and that is 60, 70, 80, haha, 90, and 100. Let's try again. 90, and then 100. Am I really able to measure this? Maybe I should crank this up a little bit. Let's see if we can get a better reading. So this is 100. Now we're going to try a 110. Now we got 110, and it need one more cycle to complete. Ooh, why didn't I get a 31? Come on. Nope. Of course it's drowning in the noise. Let's try and turn off the power supply. That is off. And are we going to see? Yes, we did actually. You see something. And then we turn it on again. Anyway, I think I'm drowning completely in noise level here and everything, but I really think it kind of works. So at least it does at DC. All we need to do now is see if we can open it. So what is inside? How did they do this? And is there any kind of beautiful in here? HP is just famous for making everything nice and shiny and super duper beautiful. So how do we open this? I think we take off this side. Wow, that is fantastic. Super, super beautiful. We have seen those before. That's definitely the classic HP switch shields. So that is not a big surprise. And of course they wrote 600 on them. And they're cascaded with shielded cables and everything. Wow, man, beautiful. But I want to see inside one of these. So I guess I need to open a little bit more. This is just beautiful HP. So this is the 1 dB step. Look how well organized the resistors are. And this will be the 10 dB step. And of course they're doing something really smart here. So this is cascaded in a really, really smart way. I don't know if we're able to see this, but they're jumping back and forward in the settings here. They're skipping steps and going back and forward. And that is, of course, a trick to avoid crosstalk and get isolation. And also we got shielding plates here in between the different sections. I mean, this is done super, super nice. I love it. Of course they did it right. Shield cable to the chassis and all this does just perfect. Yeah. Good stuff. I don't know what else to say about this. It really works. All it needs is a little bit of massage, and then it's going to be super duper fantastic.